Hi guys, I just want to take a couple of minutes to kind of guide you as you try to work on your error analyses. I wanted to talk about a couple of things that were common mistakes for people. And so I'm not going to go through the whole thing. I'm not going to do the whole work, every single problem. But what I am going to do is I'm going to talk about a couple of things that maybe will be helpful to you as you do this. Okay, so here in question number 1, most people did fine. If people didn't do fine, it's probably because on this second part, OT, they ignored the fact that, for example, if you did OP, which was P, so I went from here to here, and then if I wanted to get to T, then I needed half of PQ, right? Now, that's all fine and good, but QP is this, which goes this way. And so if I want half of that, then it's actually going to be negative 1/2 of QP. And there's a difference between this and this. Okay, and so you have to be sure to pay attention to the direction. Remember, vector has magnitude and direction. If it's the opposite direction, it needs to be negative. All right, so I'm going to scroll ahead to the second question here, which is actually from the specimen paper. This was not from November 2013. This was originally a matrix question, and we don't do matrices anymore, so I took it out. But this one, I don't know what to say other than I told you so. This is a integral through substitution. You should recognize that this is more complex than any type of integral that we know how to just do. And so we look at it and we say, well, the bottom looks more complex than the top. So I make u equal to 1 plus e to the u. And then I ignore everything. Sorry, e to the x, sorry. And then I ignore everything and I find out what the derivative is. So I say, okay, well, I'm going to find the derivative of u with respect to the x. And that gives me, well, derivative of 1 is 0, derivative of e to the x is e to the x. And oh my gosh, look what this ends up being. This ends up being then the integral of 1 over u. And then the top is e to the x, which is du dx. Sorry, 1 over u, not 1 over 2, du dx. And now you can take the integral of this. Once you've done the integral, then you can put u back in. You could do this one the same way, right? It doesn't really matter which one you choose as u, because both of them are going to be the derivative of the other. But for example, if I choose u to be, say, cosine of 3x, actually let's do sine because then I don't have to worry about the negative. So sine of 3x, then I'm going to take the derivative, so du dx equals cosine of 3x, but because the derivative of sine is cosine, because there's a 3x in there, I also need to take the derivative of the inside. The derivative of the inside, 3x is his chain rule, is then 3. And so to adjust for that, I need to now put a 3 in there. And if I put a 3, I've got to put the 1/3 in front. So you're going to have to make some adjustments. Another way to look at this is that this is just sine of theta, cosine of theta, right? And this should remind you of something that looks like this, 2 sine theta, cosine theta. And you can actually use one of your double angle rules. Of course, if I put a 2 in front, I'm going to have to put a 1/2 outside. This you should be able to then turn into 1/2 sine of 2 theta. So then you can just put the 3x back in for the theta, and you can work from there. Then you don't have to use the u substitution during your integral. You can just take the integral and remember the 1 over a thing that most of you know. Okay, so that was just kind of a little bit of help on that. Most people were fine on this one. Please just make sure not to be lazy with your numbers. Always exact or 3 digits. Again, most people were fine with this question. The people that missed this tended to be the people who were a little bit lazy, that didn't distribute this completely, that didn't actually take the integral, right? You have to then take the integral of f of x dx and take the integral of 2 dx, right? And so, of course, the integral of f of x would just be 8, and then plus the integral of 2 is 2x, which then needs to be evaluated from 1 to 6. So you evaluate that and you work it out from there. Okay, so moving on. Number 5, most people did fine on. The problems that I saw were usually maybe finding the minimum value. If you're finding the minimum value, then you just need to make sure that you're paying attention to the graph. You could sketch the graph if you wanted. You could take the derivative and set it equal to 0 to get the x values. Just make sure that you find the minimum value. Remember, if you set the derivative equal to 0, that gives you all stationary points. That's minimums, maximums, and horizontal inflections. So be careful. if you decide to do that. The easiest way, by and large, if you've already found k and you know that k is 5, then you know that the middle of the graph is at 5, right? So I know the middle of the graph is at 5. There are no vertical stretches, and so therefore, remember, sine goes up 1 and then it goes down 1 from the center. So that means it goes up to 6, it goes down to 4, and so the minimum value is 4. It's only 2 points. You shouldn't be doing a lot of work there. Okay, value of p and q. Most people got the q correctly, which was that it needed to move up 4. A couple of people missed p because they didn't make it a negative pi over 4. Remember, everything done to x is the opposite. If it's plus pi over 4, that means it needs to move to the left pi over 4. So in your vector, it needs to be negative pi over 4. Okay? All right. Number 6, I'm not going to take too much time on, just because for the most part people got it right. Remember, when you take the derivative and you get the derivative answer, you need to actually put x in, so you know the slope at x equals 1. And then from there you should be able to write an equation and rearrange it as necessary. All right. Number 7, the big problem here is that most people did something like this. They said, oh, that means that the discriminant needs to be greater than 0 because it's 2 distinct real roots. And so you went ahead and then you said, okay, well, b is k plus 2, so b squared minus 4 times a times c. And then you said, okay, that means that has to be greater than 0, which is all fine and good. However, at some point, you got to something that looked like this, and you had k minus 2 squared. If you factored it, or it could be k minus 2 times k minus 2. At this point, it's going to blow up in your face because there's a problem here. Okay, quadratics don't follow the same rules as linears do. At this point, a lot of people got k2, but you put, greater than 2 or something like this. Really, what you should do is, yeah, it's okay to recognize that this needs to be greater than 0, but I would then work as an equal sign from there. Now, yes, there's a lot of work going on between here. I'm not doing the work. I'm trying to give a hint on the part where people made errors. And so what I would do is, once you've recognized that, just put in an equal sign, right? So you solve for k equals 2. So at k equals 2, the discriminant is equal to 0, right? So what I'm going to do is I'm now going to create a sign diagram for the discriminant based off of the value of k. So at k equals 2, the discriminant is 0. Now I'm going to go into this right here because that's the simplified discriminant. I'm going to put in a number bigger than 2. Let's say 5. 5 minus 2 is 3 squared is positive. So everything to the right should be positive. Now I'm going to put in something less than 2. Let's say 0. Okay, so I'm going to put in 0 minus 2 is negative 2. Squared is positive 4. So again, it's positive, which means that no matter what, your discriminant is going to be positive unless k equals 2. So your final answer should be that k is everything except where k equals 2. Okay, so it can't be k equals 2. Anything else will make your discriminant positive. All right, so hopefully that's helpful. Remember to use the sign diagram when you're doing anything other than linear graphs. Anything other than linear graphs should have a sign diagram associated with it because the inequalities aren't going to follow the same rules. It's going to be difficult for you to figure it out from there. Okay, on to question number 8. For the most part, people did great. The part that I was most disappointed with here is the fact that they give you a domain and many of you ignored that. Okay, you have to pay attention to that when you're answering the questions. Like this, hence, all they wanted was put in the y-intercept, put in the horizontal asymptote, give me the correct domain, right? And if you do that, then you pretty much get full points on that. So just make sure that you pay attention to things like that. All right? Inverse, most people did fine, and so we're going to leave it that way. We'll go ahead. For letter E, there were a couple options. You could put 3 into the inverse function. You could also put 3 in for x in the original function. If you put 3 in for x, that should also give you the correct answer, right? And so please just remember that this is h inverse of x equals y. And so for h of x, you're just going to switch the x and y. So you could just put the 3 in for the x, and that would give you the same thing. This right here, the x-intercept, should be exactly the same as that. because it is the inverse, so the x and y are going to switch. And then the vertical asymptote should be exactly the same as your horizontal asymptote, except now it needs to be x equals 0. You don't ever even have to find the inverse function here. Now, it was pretty simple to get, but none of this requires you to actually get the inverse function. You should be able to do all of it just with that simple understanding. That's why it's only 2 points, right? It's only 2 points because really you're just copying down that information, understanding that x and y switch. Okay, so keep that in mind as you go through inverse questions. All right, question number 9. A lot of people got confused here because they read infinite geometric sequence and finite sum, and they were like, but I don't understand. Okay, it's an infinite sequence. That means it continues to go on forever. The sequence goes on and on and on and on and on. Okay, but there is a finite sum, which means if you add up all of those numbers in the infinite sequence, it will eventually give you a number. There's a limit to it. There's a finite answer. Okay? The other types of infinite geometric sequences are ones like 2, 4, 8, right, where r equals 2, where you're doubling it every time. That would be an infinite geometric sequence with an infinite sum, because those numbers just keep getting bigger. It doesn't ever get to a limit, and so you're kind of stuck there. Okay? So hopefully that's helpful reminder. Okay, from this you really just had to pay attention to r. Wording here is a little bit more important. Some of you just said, well, I need the place where r is less than 1. That's not necessarily true, because -5 is less than 1, but -5 would not give you a finite sum. It has to be either between -1 and 1, or you need to state that the absolute value is less than 1. Okay, remember, when it's less than 1, when it's between -1 and 1, that means that these terms are going to be getting closer and closer to 0, and that's why eventually you have a finite sum, because when you get to the very end, you're adding infinitely small numbers, so it doesn't matter anymore. Okay, anything bigger than 1, you're going to be getting bigger and bigger numbers, which means that you're going to be getting an infinite sum, because the numbers are going to continue getting larger. Okay, question number 10. Again, most people did fairly well on this one. I was a bit surprised. There were quite a few people that on part D here got to where they were working it out. They worked it, and then they got natural log of x equals 1, and they had no idea what to do. Come on, people. You should know what to do here. You should know that to get rid of natural log, you do e to the power of. That cancels out, leaving you with x equals e to the first, or x equals e. You should know that if you have natural log of x equals 0, you do e and e. It cancels out, giving you x equals e to the 0, which is 1. You should be able to deal with simple numbers like 0 and 1 with natural log. Okay, you should be able to figure out, well, to get x by itself, I do e to the power of both sides. Okay, for the most part, other than that, people got the question if they understood what they were supposed to be doing. Okay, there were some errors in letter E with people evaluating incorrectly and things like that, but that I think you can probably get from the textbook. It should be fairly straightforward as you're trying to figure those things out. Okay, so those are my tips for the paper 1 from November 2013. Those are the mistakes that I saw most often. I will follow this up with a similar video for paper 2. Done.